Hey everybody, this video is meant to help you out and give you an example of what I'm asking you to do for this assignment here. We're going to be rewriting quadratic expressions by completing the square using diagrams. This is an Algebra 1 strategy that we're reviewing, so you may or may have not seen this in the past. Today though, we're going to use diagrams to kind of help us out with understanding where this algebraic process comes from. So our example here wants us to rewrite the quadratic expression, this right here, in the form x plus h squared plus k. H and k are just different numbers. We don't know what they are. It'll be different for every problem. We're going to do that by completing the square. So we're going to make sense of this idea of completing the square with diagrams, so you'll actually see what a square comes to out of this expression right here. So what I'm going to do is I'm going to look at x squared plus 4x plus 3, and I'm going to create some diagrams for it. This right here, x squared, well, that's just a square. Kind of looks like this. We got a length of x and a length of x. X times x makes this area x squared. I'm not going to leave that there. I'm going to delete that. But that's why I drew it like this. We also have plus 4x. So that's 4 different x's. Well, for an x, I'm going to draw it like this, kind of as a rectangle. A little smaller. I'm drawing it like this because, well, this length I'll call 1, and this length is x. So the area is the length times the width. So this is 1 times x, which makes this area x. But I don't just have one x, I have 4 of them. So I'm just going to draw 4 rectangles like this. In fact, I can just click on this and duplicate it. There's 2, 3, and 4 of them. So I have 4 x's right here. I'll label them in a minute. And then I also have a plus 3. Well, there's no x in that, so no length of x. These are just lengths of 1, like this length right here. So these are just small little unit squares. They'll look something like this. And I'm going to have, well, 3 of those. So right now I have x squared plus 4x plus 3. And I'm going to try to arrange these all into a square. So over here, I'm going to put this right here. I'll line this right up here. Make it, doesn't have to fit perfect. Maybe make this a little bigger, but there we go. Put this here. And well, to form a square, I'm going to now turn this on its side. So I've got this here. Slide it up. I'll turn this one on its side. Notice how I'm starting to form a square out of all of these. Well, to complete this square, let's start piecing in these ones right here. All right, and what we have here now is x squared. This was x times x again. This was 1, this was 1. This length here is x. This is 1, and this is 1. And then I have 1, 2, 3. Each of these is 1. But to complete this square, I'm missing something. This square is not complete. How many more squares do we have to add back in to create a perfect square here? Well, there's just one missing from this. So right here, I'll make this red. This red square completes it. So now I have completed a perfect square right here. I can write some expressions for this square. This square, the whole thing, as a sum of all of its pieces, if I add them all together, is x squared plus, well, I have 1x, 2x, 3x, 4x. Then each of these are 1, so I have 4. So this expression for this is x squared plus 4x plus 4. And that is a perfect square right here. This is a perfect square. I could also write this another way though. Instead of writing it as a sum of all of its pieces, I can write it as a product of its dimensions. Product meaning multiplication. So right here we have its dimensions. Along this side right here, this whole length is x plus 1, 2. So this is x plus 2 as like a factor here. And then this same length right here, since it's a square, is the same thing. This is x plus 2. Those are like parentheses, just the other way around. So this expression, x squared plus 4x plus 4, is also the same thing as x plus 2 times x plus 2, which is just x plus 2 squared. Therefore, we can now rewrite this. X squared plus 4x plus 3, well, I can write that as, I'll do it by hand, x squared plus 4x plus 4. But the thing is, technically, this red square wasn't really there. It was one too few. We were short one square. So to get back to 3, technically all we're doing is just subtracting 1. If I had too many squares, like if I had 7 squares here, then I would have had a plus 3. It would be entirely different. I would have had 3 extra squares there. In our case, we were short 1, so we have a minus 1 right here. All right, and well, we know that this expression right here, x squared plus 4x plus 4, is a perfect square. It's just x plus 2 squared. So now I can rewrite the whole thing, take this piece right here, and write it as x plus 2 squared. And then we just have this minus 1 still hanging out here, representing that 1 square that was too short in order to complete it. And we have now accomplished our goal. We have rewritten the quadratic expression in this form, x plus h squared plus k. Sure, this is a minus. Technically, this is plus -1 if you wanted to rewrite it with a plus right there. But I'll leave it as -1. Same thing. All right, so you have 7 more examples to do for yourself as practice, and then you'll be done with the assignment. So go through 1, 2, 3, 4, 5, 6, 7. All right, hope this helps. Good luck. Have fun.